I'm going to be going over the radical functions test review. This should say radical, not rational. And in this review, we have 21 questions. Your test will not be this long, however. So in this review and on the test, we're going to be going over solving radical equations, function operations, finding the inverse of functions, and graphing radical functions. So for numbers 1 through 6, we're going to be solving radical equations. And you can use the worksheets that we did in class to look at the notes and to identify the steps that you have to take to solve these kinds of questions. So if you look at your worksheet on solving radical equations, step 1 is to isolate the radical on one side of the equation. Step 2, raise each side of the equation to the power of the index to eliminate the radical sign. Step 3, solve the remaining equation. And then step 4 is to check for extraneous solutions. So here it tells us to solve each equation, and then it tells us to remember to check for extraneous solutions. So checking for extraneous solutions, if you remember, is plugging in the value that you get at the end into your original equation and checking to see if that value actually works. If the value works, then it is the solution. If the value does not work, then that problem is a no solution. So we're going to start with number 1. And in number 1, we have two radicals. So step 1 was to isolate the radical on one side of the equation. When we have two radicals, we want to isolate both if possible. If not possible, we want to isolate at least one of them. So number 1, they're actually both already isolated. So what we can do is we can raise both sides of the equation to the exponent that matches the index. Our index here is 2. Remember, when you don't see an index, the index is 2. So we can raise both sides to the second power. And what happens when we do that, it gets rid of our radical. So then we're left with just 3n minus 23 is equal to 22 minus 2n. Now, step 3 tells us to solve the remaining equation. So now we just have to solve for n. I always like to keep my variable positive. So I'm going to add 2n to both sides so I can get rid of this right here. So add 2n to both sides. This eliminates plus 2n. And then that means I'm going to have to move this negative 23 to the right side. So I'm going to add 23 to both sides. This gets rid of it. And what we're left with is, so 3n plus 2n is 5n is equal to, and then 22 plus 23 is 45. We're going to divide both sides by 5. And you get n is equal to 9. So now we have to check for extraneous solutions. So, because our answer could either be D or it could be B if when we plug this in, we don't get a true statement. So let's go ahead and plug in 9 into our original function. I'm going to erase this so I can see clearly the original function. So I'm replacing this n with 9, and I'm replacing this n with 9, right? So I'm going to do 3 times 9. 3 times 9 is 27, right? So then we have the square root of 27 minus 23. The square root of 27 minus 23 becomes the square root of 4, right? 27 minus 23 is 4. So we have the square root of 4 is equal to, over here I have 22 minus 2 times 9. 2 times 9 is 18. So I have 22 minus 18. So this becomes the square root of 4, right? 22 minus 18 is 4. And we could continue and, the square root of 4 is 2, and the square root of 4 is 2. But when we got this right here, we already know that they're the same thing. So this is a real solution. So our answer is D. So I'm not going to save time on these videos, I'm not going to check for extraneous solutions. You guys should, just so you can practice doing that. But at the end, when I solve, I'm going to tell you if it is an extraneous solution or not. So for number 2, we have 20 minus 2n is equal, well, the square root of 20 minus 2n is equal to the square root of 12 minus n. So again, we have two radicals and they're both already isolated, right? So step 1 is complete. both radicals are already isolated. Step 2 is to raise each side of the equation to the power of the index. The index again is 2, so I'm going to raise both sides to the second power. That gets rid of my radicals, and I'm left with 20 minus 2n is equal to 12 minus n, right? So I want to make my variable positive, so I'm going to move this negative 2n to the right side, and I'm going to do that by adding 2n. Now, this gets eliminated, and then that means since I'm going to have n on this side, I want to get rid of this 12, so I'm going to subtract 12 from both sides. And this eliminates, so 20 minus 12 is 8, so I get 8 is equal to negative n plus 2n is just positive n, right? So here's my final answer. 8 is equal to n, or n is equal to 8. The next step would be to check for extraneous solutions. To save time, I'm not going to do that, but when you check for the extraneous solutions, this is a solution, so the answer is D. And it would not be an extraneous solution if it would be an extraneous solution and then your answer would be no solution if when you plug in 8 for these n's, you end up with different numbers on both sides of the equations, so numbers that do not equal each other, and it says that they equal each other. That's when you know you have an extraneous solution. All right, so number 3. Step 1, isolate the radical on one side of the equation. This radical is already isolated. So then we're going to move on to step 2, raise each side of the equation to the power of the index. So the power of the index here is, again, 2. So I'm going to square both sides, right? When I square both sides, it gets rid of this radical. And then I'm left with 8 squared is it's actually 64. And then when I square this, it gets rid of my radical, so I get 64 is equal to a over 4. Right, so now when I'm solving for a. A is in a fraction, so if you remember on how to get rid of denominators and fractions, you have to multiply the fraction by the denominator. So if I multiply this fraction by this denominator, I will get rid of the denominator and be left with just a, right? So I'm going to multiply both sides, and whatever I do with one side, I have to do to both sides, right? So I'm going to multiply this by 4 so I can get rid of this denominator, right? And then when I multiply both sides by 4, these eliminate each other, and 4 times 64 is 256. So I get 256 is equal to just a, right? So before, I'm going to show you why. When you multiply by the denominator, it gets rid of the denominator. So I have a over 4, right? And I'm multiplying by 4, right? So when we're multiplying fractions, you can turn any whole number into a fraction by putting it over 1, right? So I'm going to put 4 over 1. And this is the same as 4, right? 4 divided by 1 is 4. So we know that we have an equivalent fraction. We just turn the 4 into fraction. And when you're multiplying fractions, you multiply numerator times numerator and denominator times denominator. So here I have a times 4, which is 4a. And I have 4 times 1, which is 4. So now I have 4a divided by 4. And 4a divided by 4 is just a, right? So that's how I know that I got rid of my denominator. So my final answer was 256 is equal to a, or a is equal to 256. And if you plug this in, you're going to get a correct solution. So the answer is C, right? This one's actually pretty quick, so I'm going to just go ahead and check for extraneous solutions on this one. So if I plug in 256 in here, 256 divided by 4 is 64, and the square root of 64 is 8. So it checks out. You would end up getting 8 is equal to 8, which is true. So your answer is a real solution. All right, number 4. Step 1, isolate the radical on one side of the equation. So we already have this side. This radical is already isolated. So we can move on to step 2. Step 2 is to raise each side of the equation to the power of the index. So I'm going to square both sides. And then I get I get x squared is equal to, and this gets rid of the radical. So I get x squared is equal to, and I'm going to write it in standard form, right? I'm going to write my 12x first. I always like to do it in standard form. So I get 12x minus 36. This is still the same as this. I just want to write it with my x first because that's how standard form is. It still got rid of the radical, and we're left with 12x, which is right here, and negative 36. Negative 36 is here. So now we have to solve for x. And here we have an x squared. So this means we're going to have two solutions, right? And when we have a function like this, we want to factor it, right, if possible. So in order for us to factor, we're going to have everything on the same side of the equation, and it's going to have to be equal to 0, right? So to make this whole thing equal to 0, I have to move this x squared to the left side, or if I want to keep my variable positive, I'm going to move this stuff to this side, right? So because I always want to keep my leading coefficient positive, right? So I'm going to move everything to the left side. So x squared stays on this side. I'm going to subtract 12. I'm going to subtract 12x from both sides, right? And then I'm going to add 36 to both sides. So then I get x squared minus 12x plus 36 is equal to 0. And then I get, so I have this, right? So now I have to factor this if possible. So I have to think of two numbers that add up to negative 12 and multiply to 36. So both numbers have to be negative, right? Because my product is positive, but my sum is negative. And in order to get a positive product, both signs have to be the same, right? Positive times positive is a positive, negative times negative is a positive. So that means that both numbers have to be negative, right? And that also means that I'm going to look at the factors of 36. 36 is evenly divisible by 6, right? 6 times 6, that is, and well, negative 6 times negative 6 is 36, and negative 6 plus negative 6 is negative 12. So my answer here is x minus 6 times x minus 6, right? So we would have two solutions, and we will have two solutions, except it's going to be the same solution twice. So I only have to plug one of these in, right? So x minus 6 is equal to 0, or I could do both, right? X minus 6 is equal to 0. So now I'm solving for x. I'm going to add 6 to both sides. Over here, I'm going to add 6 to both sides as well. And then I get x is equal to 6, and x is equal to 6. So 6 is a solution twice. And then you would check for extraneous solutions, meaning you would plug in 6 in for the x's here. And once you do that, you would get a true two numbers that equal each other. So this is going to be true. So we get, our answer is B, 6. All right, for number 5. All right, so now we do have to actually do step 1, because remember, step 1 is to isolate the radical on one side of the equation. So my radical is here. It has this 10, right? So in order to get rid of this 10, I have to subtract 10 from both sides. And I get, let me write it over here. So I get b, that looks like a 6. I get b minus 10 is equal to the square root of 20 minus 2b. All right, so step 2 is to square both sides. Well, to raise each side of the equation to the power of the index, but since this is square root, I'm squaring both sides. All right, so now I have b minus 10 squared, so, and the square root of 20 minus 2b squared. So over here on this side, it gets rid of my radical. However, over here, I have, this is the same as b minus 10 times b minus 10. So I'm going to do that over here really quickly. You guys can do this on a separate sheet of paper. I'm going to have to erase, so make sure to write this down so you can remember it. But I have b minus 10 times b minus 10, right? So I'm going to use the distributive property, and I'm going to FOIL. So I have b times b, which is b squared. B times negative 10, which is negative 10b. Negative 10 times b, which is negative 10b. And then negative 10 times negative 10, which is plus 100, right? These two combine, and I get b squared minus 20b, right? Negative 10b minus 10b is negative 20b plus 100. All right, so let me go ahead and rewrite it over here. So I get b squared minus 20b plus 100 is equal to, I have to find more space, so I'm going to erase this, and I'm going to write it down here. So I'm going to rewrite it down here, b squared minus 20b plus 100 is equal to, and then we're left with just the radicand here, so is equal to 20 minus 2b. All right, so now we're going to solve for b. So again, we're going to have two solutions, right, because we have b squared, and we have to move everything to the left side over here. We have to have everything on the same side. So I'm going to add 2b to both sides. Right, this gets rid of this, and I'm going to subtract 20 from both sides. This gets rid of this. So now I have b squared, and then 20b plus 2b is negative 18b. And then we have 100 minus 20, which is plus 80, right? So now I have to think of two numbers that add up to negative 18 and multiply to 80, right? So again, both numbers have to be negative, right? Because we have a negative sum and a positive product. So it has to be negative times negative, right? Which is a positive, and they have to add up to a negative number. So so the two numbers that do this is 10 and 8, right? Negative 10 minus 8 is negative 18, and negative 10 times negative 8 is positive 80. So this becomes b minus 10 times b minus 8. All right, so for this one, I'm going to check for extraneous solutions. Just, I need to erase some stuff, so I'm going to erase this right here. I'm going to erase this as well. All right, so I'm checking for extraneous solutions, right? So that means that I'm plugging in. First, I'm going to check number negative b minus 10, right? Oh, and you would solve, right? So b minus 10 is equal to 0. So you get b is equal to positive 10, right? Because you add 10 to both sides. And then over here, you'd get b minus 8 is equal to 0. And you would get b is equal to positive 8, right? You add 8 to both sides. All right, so our two answers, let me erase this again. Our two answers are positive 10 and positive 8. So b is equal to 10 and 8. So I'm going to start off with plugging in 10 for b, right? So b is 10, right? So I'm replacing this with 10, and I'm replacing this with 10. So I have 10 is equal to 10 plus the square root of 20 minus 2 times 10. 2 times 10 is 20, right? And then 20 minus 20 is 0. So this becomes the square root of 0, which is just 0, right? So this gets canceled out, and then I'm left with just 10. And the statement that I get is 10 is equal to 10. And that is true, right? So 10 is a solution to this, right? So 10 is a solution. Next, I'm going to plug in 8 in for the b's, right? So I get 8 is equal to 10 plus 20 minus 2 times 8, right? So 2 times 8 is 16. So I have 20 minus 16, which is 4. So this becomes the square root of 4, and I know that the square root of 4 is 2, right? So I get 8 is equal to 10 plus 2. 10 plus 2 is 12. So I end up getting 8 is equal to 12, which is not true. So that means that 8 is not a solution. So my only solution is 10. So that means that b is equal to 10, and which is answer B. And this is why you have to check for extraneous solutions every time, because there's actually 3 possible answers that you could have gotten when you got your final answer. You could have gotten 8 and 10, right? Because that's what we got. However, when we checked for extraneous solutions, we saw that 8 is not a solution, so it couldn't be C. No solution was a possible answer if 10 would have not checked out, right? But 10 did check out, so this was not an answer either. And that left us with just the answer being B, 10. So it's important to check for extraneous solutions. Make sure to do that on your test. All right, I'm going to erase some stuff over here. All right, number 6. So for number 6, step 1 is to isolate the radical on one side of the equation. So I'm going to add x to both sides, right? So I get the square root of negative 2x. I'm going to write it up a little higher. So I get the square root of negative 2x plus 56 is equal to, I added x to both sides, eliminate over here. So I get x minus 4. So now step 2 is to raise both sides to the power of the index. The index is 2, so I'm going to square both sides. And I get, over here, it gets rid of the radical, right? So I'm left with negative 2x plus 56. And then I have x minus 4 squared, which is going to be x squared minus 8x plus 16, right? I can do this in my head, but you would have to write this as x minus 4 times x minus 4. Distribute x, you get x squared. X times negative 4 is negative 4x. Negative 4 times x is negative 4x. And then negative 4 times negative 4 is plus 16, right? So these add up to negative 8x. So I got x squared minus 8x plus 16. So the way I did it in my head is when you have x plus or minus something squared, you know that you're going to get x squared. And since this number is going to be multiplied by x 2 times, you do 2 times this, right? So 2 times negative 4 gives me negative 8. That's what I did in my head. And then you do this times itself. Negative 4 times negative 4 gives you 16. So whenever you have a x minus or plus something and it's squared, the way that I do it in my head is I do x squared because it's going to be multiplying x times x. And then I do 2 times the number, the constant, right? So negative 4 times 2 was negative 8x. And then at the end, you do this times itself. Negative 4 times negative 4 is positive 16. So just a little shortcut. If that didn't make sense, don't worry about it. That's just a shortcut that I use. But you can write it all out and still get the same number. So now I'm going to go ahead and move this to the right side of the equation, right? Because I have x squared, meaning I'm going to get 2 solutions. And I want to solve by factoring if possible, right? So I'm going to add 2x to both sides to get rid of this. And when I add 2x, this eliminates. Then I'm going to subtract 56 from both sides. Right, so then I get 0 is equal to x squared. And then negative 8x plus 2x is negative 6x. And then 16 minus 56 is going to be negative 40, right? So now I have to think of 2 numbers that add up to 6 and multiply to negative 40. So let me think. So one has to be positive and one has to be negative, right? Because in order to get a negative product, it has to be a negative times a positive, right? And the higher number has to be negative since the sum of the 2 numbers is negative. So the multiples of 40, 10 and 4, right? So 10 and 4, negative 10 times positive 4 is negative 40, and then negative 10 plus 4 is negative 6, right? So the factor form here is x minus 10, x plus 4, right? Negative 10 times 4 is negative 40. Negative 10 plus 4 is negative 6. So then you solve for your x's. You get x minus 10 is equal to 0. Add 10 to both sides. You get x is equal to 10. Then you have x plus 4 is equal to 0. Subtract 4 from both sides. And you get x is equal to negative 4. Right? So your 2 answers here are x equals 10 and negative 4. So we're going to check for extraneous solutions, right? So first, let's check on number 10. So we're going to plug in 10 into this function. So this becomes 10, and this becomes 10, right? So this is the square root of negative 2 times 10 plus 56. Negative 2 times 10 is going to be, negative 2 times 10 is negative 20. So now I have negative 20 plus 56. Negative 20 plus 56 is 36, right? So now I have, well, it's the square root of 36, right? The square root of 36 is 6. So then I get 6 minus 10 is equal to negative 4. And 6 minus 10 is negative 4, right? So this checks out. So 10 is a solution. All right, so this checked out, right? So next, I'm going to check on negative 4. So I'm going to plug in negative 4 into this function. So this is negative 4, and this is negative 4. It's going to be minus negative 4, which is the same as plus 4, right? So just keep that in mind. All right, so now I have negative 2 times negative 4, which is positive 8. So 8 plus 56 is 64. So I have the square root of 64, which I know is 8. And I have 8 minus negative 4, which is the same as plus 4, right? So this is 8 plus 4, which is 12. So I get 12 is equal to negative 4. This is not true. So negative 4 is not a solution. So my only solution is x is equal to 10. So the answer is oh, and look, we had two answers for x, and 4 wasn't an option in any of them. So we could just, if you would have thought about it, you would have been like, okay, well, 10's the only option. So my answer is D. All right, so moving on to number 7. For number 7, we are doing function operations. Number 7 through 12, we're doing function operations, maybe even more. Yeah, 7 through 14, we're doing function operations. So with function operations, we're going to be performing the indicated operation. Remember, with function operations, you're given a set of functions, and you are going to perform the operation as indicated, whether it's addition, subtraction, multiplication, division, or composition. All right, so for number 7, we have g plus h of x, right? So we're given function g. Function g is 3x minus 5. Function h is 3x minus 2, right? And we're combining them by addition. So we're going to take function g and we're going to add function h to it, right? So I'm going to write it out. So g plus h becomes 3x minus 5 plus, function h is 3x minus 2. So plus 3x minus 2. So these ones are pretty simple, right? Because we're just going to be combining like terms. So I have 3x plus 3x, which is 6x. And then I have negative 5 plus negative 2. Negative 5 plus negative 2 is going to be negative 7. So my answer is 6x minus 7, which is option B, right? Pretty simple. Next, I'm moving on to number 8. So number 8, we're given a set of function. We're given function g and function h. So function g is negative 3x plus 4. Function h is 3x plus 3. And we're combining by subtraction, right? Because we have g minus h of x. So I'm taking function g and I'm subtracting function h from it. And remember, these are when you're doing subtraction or division, the order is important. In addition and multiplication, the order doesn't matter, but when you're subtracting or dividing, it does matter. So we got to make sure that we write function g first and that we're subtracting function h from it. All right, so this is g minus h. Let me write it a little higher. G minus h. So g is negative 3x plus 4. And I'm subtracting function h from it, which is 3x plus 3. Okay. So we're going to combine like terms. And I have negative 3x minus 3x, which is, don't get confused here. I know some of you may think that you're going to be eliminating the x's. However, that is not true. Negative 3x, think of negative 3 minus 3, just negative 6x, right? And then we have 4 minus 3, right? So 4 minus 3 is just 1. So plus 1. So our answer is negative 6x plus 1, which is option B. Oh, sorry, that's option D. This is minus 1. Plus 1 right here. So our answer is option D. All right, for number 9. Oh, and I can color code again like I did in class. So I'm going to use, so function f, I'm going to use blue, and function g, I'm going to use red. All right, so, so for number 9, I have two functions. I'm given function f and function g, and it tells me to find f plus g of t, right? Don't get confused by this t. It's the same as x, right? It's just our variable. So we're solving for f plus g of t. So f of t is equal to negative t cubed minus 4t squared minus t, and then g of t is t minus 1. So again, don't get confused by the t's. That's just replacing x. So t is our variable, right? All right, so I'm doing addition. It doesn't matter the order you write it in, but I'm going to write it in the same order. So negative t cubed. So negative t cubed minus 4t squared minus t plus, our function is plus, t minus 1. Right, so we're going to combine the like terms. So the only like terms that they share are t and t, right? So that means that I'm gonna drop this down, right? Because this is negative t cubed plus 0, which is just negative t cubed. Then I have negative 4t squared plus 0 again, so it's just negative 4t squared. And then I have negative t plus t. That means the t's cancel each other out, right? Think of this as negative 1 plus 1 is 0, right? So these eliminate each other. And then I have plus negative 1. It's like there's no constant over here, so it's 0. 0 plus negative 1 is negative 1, right? And so this is our answer right here. And that is option B. Negative t cubed minus 4t squared minus 1. All right, moving on to number 10. So I'll do G in blue and H in red. So again, don't get confused by the n. N is just our variable, right? Think of if it makes it easier, you can think of these as x, right? But those are just our variables, so don't get confused by it. So we have g of n is equal to 2n minus 4. H of n is equal to negative 2n squared plus 5. So what we're doing here is we're dividing g of n by h of n. Right, this tells us g divided by h of n. So what we're going to do is we're going to put function g over function h, right? So function g is 2n minus 4 over 2n squared plus 5. So we can factor this, right? We can factor a 2 out of it, and it's 2 times n minus 2. However, we can't factor anything out of this. So that means we can't simplify it any further, right? This does not share any factors with this or this. So we're done. We don't have to do anything else. Our answer is 2n minus 4 over 2n squared plus 5, which is option... Oh, and I forgot the negative right here, right? So this is supposed to be negative. Our answer is 2n minus 4 over negative 2n squared plus 5, which is option B, right? I'm going to match them in blue, right? So 2n minus 4, right? And then negative 2n squared right here plus 5. So our answer is B. Just always, when you have a division problem, you always want to see if you can factor it. If you can factor it and eliminate things, make sure to do that. All right, number 11. So for number 11, we have function g of x and h of x. G of x is 2x minus 1. H of x is 3x minus 5. And it tells us to find g divided by h of x. So we're putting function g over function h. And if you look at function g and function h without doing anything, they don't share any common factors, right? They're already in simplest form. You can't factor anything out of here. Can't factor anything out of here. And they're not divisible by each other evenly. So we're going to be done as soon as we write our functions out, right? So I have function g, which is 2x minus 1, over function h, which is 3x minus 5. And this is our final answer. So let's look for the option that matches that. And that is option C. All right, so 2x minus 1, which matches this. 3x minus 5, which matches this. So option C. All right, number 12. So for number 12, we're given two functions again. G of t is equal to 4t plus 1. H of t is equal to 3t plus 3. So it tells us to find g divided by h of t, right? So again, if you look at these, they don't share any factors, and you can't factor anything out of them. They're in its simplest form. It can't be divided evenly, so when we write it out, it's going to be our final answer, right? So I'm not even going to color code it. So I'm putting function g, 4t plus 1, over function h, which is 3t plus 3. And that is going to be option C, right? All right, so we're going to move on to the next side. Wow, we didn't do any compositions. I'm gonna add compositions, and we'll review that in class together. Now I'll make a separate video on that as well. So for number 13, we're evaluating. So we're evaluating h of g for the value 7, right? So we have h of a is equal to negative 2a plus 2, and g of a is equal to 3a plus 3. So what we're doing is, there's two ways that we can solve this, right? When we're evaluating, you can either take function h and divide it by function g and solve what that is, and then plug in 7 for the a's, or you can plug in 7 into function h for the a's, right? So negative 2 times 7, and get a value, and then you could do function g, plug in you can plug in 3a or 7 into a, right? Evaluate it for 7, and then you're going to get a value for g. Then you just put the value of h over the value of g. All right, so for number 13, I'm going to do it both ways really quickly because this one's going to be pretty simple, right? So the first way would be you put this over this, right? Function h over function g. Function h is negative 2a plus 2 over 3a plus 3, right? Normally here you would solve, right? You would simplify this, but it can't be simplified any further. So what we're going to do is we're going to replace the a's with 7, right? So this becomes negative 2 times 7 plus 2 over 3 times 7 plus 3. Right. So negative 2 times 7 is negative 14. Maybe write that negative. Negative 2 times 7 is negative 14. Negative 14 plus 2. Negative 14 plus 2 is negative 12. Over. So 3 times 7 is 21. 21 plus 3 is 24. All right, so I have negative 12 over 24. Doesn't match any of these options here. However, negative 12 and negative 24 are both evenly divisible by 12. 12 divided by 12 is 1, right? So I have negative 1 over 24 divided by 12 is 2. So negative 1/2, right? Option D. All right, number 14. For number 14, we have g of n is equal to n plus 2, and h of n is equal to 3n minus 5. And it tells us to find g divided by h of 1, right? So we're plugging in 1. Oh, and I forgot to show you guys the other way. So let me show you the other way for number 13 first. So the other way would be to first just plug in 7 here. I mean, we kind of did it, but let's just do it. So we're replacing this with 7, right? So I have negative 2 times 7, which is negative 14, plus 2, which is equal to negative 12. So this is my value for h. Next, we're going to do the same thing for function g. We're going to plug in 7 here, right? So I'm taking 7 and replacing it with a. So I have 3 times 7, which is 21. And then plus 3, 21 plus 3 is 24. This is value g. And we're doing h minus g, or no, sorry, not h minus g, h over g. And when we do h over g, we're going to plug in the value for h and the value for g, right? So the value for h is negative 12 over the value for g, which is 24. And we got the same thing that we got in the last example, right? Or the other method that we used. So negative 12 over 24 simplifies to negative 1/2, which is option D. It's more useful to use this method when you have multiplication, when you're multiplying two functions together, because it's just going to save you a lot of work. All right. So for number 14, I'm just going to I'm going to do it the other method. So I'm going to plug in 1 for the ends and then put my value of g over my value of h, right? So this becomes 1. 1 plus 3 is 3, right? Or sorry, 1 plus 2 is 3, right? So this is my value for g. Next, I have 1 right here. So 3 times 1 is 3. And then 3 minus 5 is going to be negative 2, right? So this is my h value. So I'm putting value g over value h. Right? It tells us right here to do that. So my value g is 3. And my value h is negative 2. So I have 3 over negative 2, which is just, can't simplify that any further, so that's just negative 3 over 2, right? Which is option B. So these are going to be pretty simple. You just got to find the method that you think is best suited for you, and then do that.